Hi everyone, and welcome to an introduction to orbital diagrams. So our next unit that we're covering this year is electrons, and right now we know that electrons are existing outside of the nucleus of an atom. They are constantly orbiting it, but we don't really know too much about their placement and location. So an orbital diagram is essentially going to be a model for us to visualize placement of electrons and energy and their shapes. Okay, so you guys have a student handout that you are going to be filling out along with this presentation. So make sure you have a pencil ready and you have that paper in front of you before you continue the video. Alright, so most of you have a periodic table that looks like this, and we colored in the 4 different blocks. So there's the S, P, D, and the F block. Groups 1 and 2 make up your S block, so I had you guys color that in red. And then we also cannot forget that helium, which is usually located over here, but I moved over just to be with the rest of its section. We cannot forget that that is part of the S block. To the right, we have the P block. Right, so all of these elements, groups 13 through 18, except for helium, are part of the P block. And then groups 3 through 12 in the middle is our D block. And then all the way at the bottom is our F block. All right, so those are our lanthanides and actinide series. All right, something else I also asked you to label were these numbers going down the sides. All right, and these numbers are super important because these represent our energy levels. All right, and as we move down the periodic table, we are increasing in energy. So the elements to the top of the periodic table, they have the least amount of energy. They're energy level 1, and then as you move down, we are increasing in energy with every period. Okay, electrons are characterized by their shape. So there are 4 shapes, which are also called orbitals, that electrons can exist. So they are the s orbital, the p orbital, the d orbital, and the f orbital. At the bottom of the slide here, I have a diagram which shows some of the possible configurations and shapes that they might be in. And each orbital, you are not going to have to remember what these shapes look like. As you can see, they get more and more complicated as the energy increases. Again, you do not have to know what these shapes are, but you do have to understand that the letters S, P, D, and F are referencing the shape of the orbital. Okay, each orbital can contain a maximum of 2 electrons, and a group of orbitals together with similar energy is called a sublevel. The number of electrons which can exist in a sublevel depends on the type. Yesterday you guys participated in the Dover Hilton Hotel activity, so let's connect some of the terminology that we used in that activity to the new vocabulary that I am teaching to you today. In your hotel, we called these orbitals rooms, so imagine each orbital is a room from that activity. Each sublevel is a group of rooms which is on the same floor, meaning that they have the same amount of energy. Our floors were representing the energy level. All right, so the first floor being on the bottom has the least amount of energy, and the 7th floor being our top floor has the most. We used arrows to represent the guests, which of course those arrows are actually representing electrons in these models. All right, let's talk about each of the orbitals one by one and what they're going to look like in our diagrams. So every s orbital contains 1 orbital, or 1 room from our hotel activity. So it can hold a maximum of 2 electrons. So our s orbitals are just going to have one line. You're going to write the energy level, s orbitals start at 1, and then the letter s. When we increase in energy, we now open up the p orbitals. The p subshell or sublevel contains 3 orbitals. Since each orbital can hold 2 electrons, this means that each p sublevel can contain a maximum of 6 electrons. So when we draw the orbital diagram, we have to write 3 lines, and the p orbital doesn't start until the second energy level, so the lowest number that you can write is 2, and then the letter p. D orbitals. So the d sublevel contains 5 orbitals. Since each orbital can hold 2 electrons, this means that each d sublevel can contain a maximum of 10 electrons. Alright, so we have to draw 5 lines. And the d sublevel does not open up until we reach the 3rd energy level, so the lowest number you can write there is going to be 3, and then the letter D. And then lastly, the f orbital. The f sublevel contains 7 orbitals. Since each orbital can hold 2 electrons, this means that each f sublevel can contain a maximum of 14 electrons. Alright, so every f sublevel has to have 7 orbitals. And the f sublevel doesn't open up until the 4th energy level. So the lowest energy level you can write there is 4, and then the letter F. Okay, so now let's talk about how to fill orbital diagrams. So what's important to know is that the periodic table is read from left to right, just like a book. And I gave you guys a periodic table that looks like this because this is how it's actually supposed to be organized. That F block is actually supposed to be placed between the S and the D block. However, if we were to print periodic tables like this, it would be very squished and difficult to read. So that's why they pulled it out and put it towards the bottom. Alright, but just like a book, we start in the top left corner. So we start at the 1s, which is element number 1, hydrogen. And then we read all the way across from left to right. Alright, and you can tell that you're going in the right direction because the atomic numbers are increasing by 1. Alright, so we went from element 1 to element 2, and then after we get through helium, we now are going to look at the next. We are now going to look at the next line. Alright, starting with element 3, lithium. After lithium and beryllium, you're going to read all the way across. So that way you go in order 3, 4, 5. Now we are in the 2p. You're going to read all the way to the end of the 2p before going down to the 3s. So each of these energy levels have to be, or sublevels have to be filled in order according to their location on the periodic table. Alright, and the trickiest part about this whole process is going to be remembering that after 6s, you have to go down through 4f before reading through 5d. Alright, here are some rules for filling orbital diagrams which must be followed. So rule number 1 is called the Aufbau principle. Aufbau means filling up. So we must start by putting electrons in the lowest energy level. Once the lowest energy level is filled, then the next one can begin to accept electrons. Just like in our hotel activity, we were putting guests in the lowest energy level first, or the lowest floor first, and then filling them up from there. They were not going up to the second floor until the first floor was completely booked. And a hint to remember that the Aufbau principle is about starting from number 1, energy level 1. I like to think that A is the first letter of the alphabet and we start at 1. The second rule is Hund's rule, which is also the bus seat rule. So all orbitals in the same sublevel must have one electron in it before they may be paired. So think if you're getting onto a bus, you're not going to squeeze in a two-seater next to somebody else until all the other seats are filled, right? You would rather have an empty seat to yourself than have to squeeze next to somebody else in a seat. Electrons are the same way. They would rather have their own orbital than have to squeeze next to another electron. And these single electrons must also have the same spin. So all these single electrons, they either need to be spinning up, so the arrows need to be pointing up, or they all need to be pointing down. You cannot have one or two facing in opposite directions. The last one is the Pauli exclusion principle. So this one says that all paired electrons must have opposite spins. So when they are paired, they need to be opposite. If they are separated, they need to be the same. And then just a hint to remember what this rule is. I'm a huge Jersey Shore fan. Pauly D, he's a DJ. So DJ Pauly D, he spins the turntable. The Pauli exclusion principle is about the spin of electrons and how when they're paired, they must be opposite. So these are just some hints to help you remember which rule is which for whenever you take your quiz. All right, to end this video, let's see how this is applied. All right, so we're going to do an example. Carbon, element C, we're going to fill an orbital diagram. So here I have a template laid out. You will not get a template on your test. You will have to do it from scratch. All right, but just for the purposes of showing you how to fill these diagrams, I'm going to do this using a template for right now. All right, so step 1, determine how many electrons the element has. All right, so remember that the number of electrons is equal to the number of protons, which is equal to the atomic number in a neutral atom. So if I take out my periodic table, I will see that carbon is atomic number 6. So that means carbon has 6 electrons. Step 2, always start from the lowest energy orbital. So always start in the 1s. So my first electron is going to be right there. And then step 3, continue to add electrons until the necessary amount of electrons is met. Remember the 3 rules. So I cannot put another electron into 2s until 1s is filled. So I'm going to put my second electron in the 1s. All right, so now I have 2. I need to keep going until I reach 6. My next 2 are going to be in the 2s. All right, so now I have 1, 2, 3, 4. All right, so now my final 2 electrons have to be in the 2p. So I'm going to put them in 2 separate orbitals, both facing the same direction. And that's it. I don't need any of the other orbitals that were in this template. That is my final answer, my orbital diagram for carbon. All right, and that's it for this video. So make sure that you didn't miss any blanks or anything in your notes, and keep this in a safe spot. You can put it in your folder in the classroom so that way you have it to reference. These are notes that you're going to have. These are notes that I'm going to ask you to take out periodically throughout the entire unit, and of course it's going to be a great reference for when you're working on your study guide for your quiz and your test. Tomorrow in class we're going to dive deeper, and we're going to do some examples where you are going to be creating these orbital diagrams and filling them from scratch. All right, I will see you tomorrow. Have a great day.